Welcome to the Day in History for April 16th. Okay, the big idea today is genius is real. And I say that because we're talking about Isaac Newton. Now, I did have another day in history already done for this, and it was about the Bay of Pigs and communism and nuclear war, but it was pretty depressing. So I decided to do something a little more exciting. So today is actually the day that Queen Anne of England knights Sir Isaac Newton. We always say Sir Isaac Newton, but before today, he was just Isaac Newton because he hadn't been knighted. Now, I will step aside. You can write this down. Okay, today's day in history. Now, we are in Cambridge at Trinity College in England. Now, this is actually the location of where Queen Anne knighted Sir Isaac Newton, but it was also a place where Isaac Newton worked, and it's a really cool looking school. I got another picture of it here in a minute, but let's move on. Now, Sir Isaac Newton is very, very famous. Most people have heard of him. Most people can tell you some of the things he's done, and he had a really interesting life, and he was, many people say, a true genius. There's been quite a few geniuses throughout history. I think Isaac Newton could be included as one of those geniuses. So, now, he was born in 1642 in Woolsthorpe Manor in Lincolnshire. It's in England, it's outside of London. Now, this is actually the house that he was born in and grew up in. Pretty cool that it's still standing. Now, his dad was a farmer, and when Sir Isaac Newton was a child, he worked kind of like a waiter. He did a little bit of cleaning for people that had a little more money. So he worked as a child, but eventually he did go to school. And he went to Trinity College, which today we know as Cambridge. Now, this place is really cool looking. When I was doing the Google Earth to get our picture for the second slide, I zoomed in on Trinity College, and it looks like straight out of Hogwarts. I mean, it's a really, really cool. Maybe see if you can find like a virtual tour of Cambridge. It's pretty awesome. Now, he worked there, and he went to school. He eventually became a professor, but in 1665, he had to leave for social distancing. Yeah, I said it. Social distancing, because in 1665 there was a reoccurrence, or the Black Plague came back. The bubonic plague came back to England and other parts of Europe, and so people had to go away. They had to go home to stay safe. Now, Newton had to social distance. He had to self-isolate to protect himself and his family from the bubonic plague. And while he was home, he made a lot of amazing discoveries. Now, I'm not 100% if he made this discovery while at home, but we're going to talk about his discoveries next. Now, one of the things that he invented and discovered was calculus. Calculus. This is calculus. Now, this equation, I did a lot of studying on this. This equation has to do with actually, I have no idea what this means. I only made it through advanced trigonometry in high school. I wasn't very good at math in college, and I never did calculus or pre-calculus or any of that work, but I guarantee you some of you guys watching this will do this math. But Newton came up with some of the basic fundamental mathematical principles of calculus, which is a highly advanced type of mathematics. Pretty cool stuff. This is awesome, though. He figured out that white light can be broken up into colors, and that the colors can be put back into white light. Before that, people didn't know this. They had never used a triangular prism to break up light into its different parts, or the light spectrum. So this was a huge, huge discovery that really blew people away. To be able to take this crystal and have light come in and then see colors was absolutely amazing. And it was pretty cool. And remember, we're in the year like 1670. I mean, it's not modern times yet. So pretty cool discovery. Now, he also published something called a treatise on optics, or a whole book about optics. Now, Newton was very interested in the stars and seeing far away, and he developed some pretty cool ideas about how to use lenses to make telescopes. Now, if you remember any of the macro-micro lessons from Camp Out, fourth graders, sorry you didn't get this lesson, but we talked about the early invention of optics and about the eyeglasses and how people would take these and make telescopes. Well, Newton created the Newtonian telescope. I actually have a Newtonian telescope in my garage. They work really well. And he figured out how to bounce light off mirrors to be able to see far away. And this actually won him a lot of favor at the English court. It was a pretty big deal, because these telescopes are what enabled us to look at the stars and to discover more about our solar system and our universe. Pretty cool stuff. Now, one of his most important things that he did was natural principles of mathematics. Now, he was hugely into math, and he discovered a lot of things in math. And this document that he came up with changed the way that we did math in the modern world. Pretty interesting. This would make an excellent research topic to actually discover what was actually in the Philosophy Naturalis Principia Mathematica. Pretty cool. Now, we're to the time where we're going to talk about Newton's laws. Now, the first law we've talked about before. You know, I'm sorry for the kind of cheesy picture, but this one was one of the best pictures I could find on the internet that just gave you a really quick overview of the three laws. Now, the first law is the one we know the most. Every body remains in a state of rest or uniform motion unless acted upon by a net external force. I'm reading this from my notes behind here, so it might look a little strange, but I want to make sure that I read the law how it's written. This first law, every body remains, not everybody, every body or every object remains in a state of rest or uniform motion unless acted upon by a net external force. Okay, a body in motion stays in motion unless acted on by an outside force. This is the part of the presentation where I throw something. Now, Newton said that this will stay in motion unless acted on by an outside force. You ready? Yeah, I see. It fell, it stopped. You ready? Yeah, it stopped. Let's see if this one does it too. Okay. So, as you can see, Newton proved that things, bodies, object in motion will stay in motion until acted on by an outside force. So watch this. I'm going to put these in motion. The force that they're going to run into is gravity pulling down and this wall. You ready? See? Okay. Now, second law of motion, I got to read this one. The amount of acceleration of a body is proportional to the acting force and inversely proportional to the mass of the body. So pretty much what this means is if you're moving something, there's going to be different forces pushing on you based on how big the object is and how much force you have. I don't know too much about the second law. We can do some more research on that. The third law is pretty interesting too. For every action, there is an equal but opposite reaction. If an object, okay, we'll just leave it there. For every action, there is an equal and opposite reaction. You see the picture here? I'm pulling the dog is pulling me. There is a force, there is an action, an opposite and equal force being pulled. This gets a little complicated. I think you should do some more research on this, but I like the first law because I always get to throw things. Okay, now, this one's really cool. Now, this is the laws of planetary motion, or pretty much gravity. Okay, what Newton figured out was how gravitational bodies, how large objects can affect each other. Now, if you look at this equation, we have M1 and M2. You see them up there? M1 and M2? Okay, M1 and M2, which is mass 1 and mass 2. And do you see the F with the little g? That's the total amount of gravitational force. So they're saying Newton's saying the total amount of gravitational force is equal to the gravity of the mass of the first body times the mass of the second body divided by the distance between them squared. Fancy equation. Pretty much what Newton discovered and wrote an equation for was how different objects in space react to each other based on gravity. You got this? You got this figured out? Okay, another great research topic. Okay, now, after all these discoveries, Newton was eventually elected to the English Parliament and took on a role that kind of moved away from these amazing discoveries that he'd done in the past. And as time went on, it said that he kind of got depressed. He kind of actually had like a mental breakdown and changed his focus from these scientific principles to things that were more religious and more based on, well, like alchemy. Yeah, it got pretty interesting. He really focused on the 4 elements because what he realized and what others had realized is that if you take the earth, wind, fire, and water, everything we know is made up of those 4 elements. And he got really interested in how those 4 elements could be used to create new elements. And this actually led to some of the work on trying to turn like lead into gold. Can you imagine if you could take worthless metal and turn it into gold? You'd be rich immediately. Now, something else he worked on, which got a little interesting, is called the Philosopher's Stone. Yeah, the Philosopher's Stone. Sounds like something out of Harry Potter, right? And what it was there's this fabled object, this fabled Philosopher's Stone, like this red stone that was said to have all these different abilities, to have the ability, if you combine it with different elements, to turn lead into gold or to cure illnesses. It was like a magic mythical object. And it really captivated Newton as he searched for a way to find it, to make it, to create things from these 4 elements. This part of his life isn't talked about as much. And I think it's really interesting. I'd like to do some more research on this because I know quite a bit about his like major discoveries, but this is a little bit strange. I watched a couple videos on the Philosopher's Stone, and it's some I don't know, kind of conspiracy theory sounding stuff. I mean, it's really interesting. But another great research topic. That's like the 5th great research topic. Okay, so we finally get to today's day in history, which is in 1705, Queen Anne knights Sir Isaac Newton at Trinity College, and forever and after, he is known as Sir Isaac Newton. Now, this is a day in history about a true genius in our history. I mean, he is known by just about everybody. I bet you can go out to anybody that's in 3rd grade or above and say, "You ever heard of Isaac Newton?" They say, "Of course I have." So, Isaac Newton, day in history. Today is the day he got knighted. Ladies and gentlemen, have a good day. See you later.